You know, every single time you browse the web or use an app on your phone, you're putting your trust in millions of lines of code you'll never ever see. But what if the very foundations of that code have hidden cracks? Today, we're going to look at a pretty revolutionary new tool that's kind of like a seismic sensor for software, finding those dangerous vulnerabilities before they can cause a massive digital earthquake. So think about how modern software actually gets built. Developers don't start from a blank page. Nope, they use software libraries, which are basically pre-built kits of code, just like Legos. A super important library like OpenSSL, which secures a huge chunk of the internet, is like a foundational Lego kit that thousands of apps just snap into place to handle encryption. And that's super efficient, right? But what if one of those essential Lego bricks is weak? A single vulnerability in a library like OpenSSL doesn't just mess with one app. It can put millions, literally millions of systems at risk. So you can imagine, finding these flaws is one of the most critical jobs in all of cybersecurity. Okay, so here's our game plan. First, we're going to dig into the hidden code problem. Then we'll unpack the big dilemma that's had testers scratching their heads for years. After that, we'll meet our hero, NEXZZER, and its secret weapon, the learning graph. And finally, we'll look at the cold hard numbers to see if this new approach really is a game changer. All right, let's dive right in with the heart of the issue, the hidden code problem. This is all about the huge challenge of finding flaws in those foundational Lego bricks that our entire digital world is built on. The go-to method for this is a technique called fuzzing. Imagine you're stress testing a new bridge. You could just drive a few regular cars over it, and yeah, it'd probably be fine. But what if you send a million different vehicles? I'm talking everything from a unicycle to a monster truck driving backwards just to see what makes it break. Well, that's fuzzing. It's an automated way to just throw chaotic, random stuff at software to see what makes it crash. But here's where it gets kind of tricky. A crash doesn't always mean you found a real bug. See, there's a huge difference between a genuine API vulnerability and something called API misuse. API misuse is basically the testing tool using the library the wrong way. Think of it like this. If you use a screwdriver as a hammer and hurt your thumb, you can't really blame the screwdriver company, right? This difference is absolutely crucial for developers who need to be fixing real flaws, not chasing down a bunch of false alarms caused by their own tools. And that right there leads us directly to the fuzzing dilemma. This is the big trade-off, the central conflict that has been dogging automated software testing for years. So, historically, fuzzers have pretty much fallen into two camps. On one side, you have the replicators. They're the safe ones. They look at how a library is already being used and just copy those patterns. Super accurate, not a lot of false alarms, but because they're not creative, they have low diversity and miss all sorts of new bugs. Then on the other side, you have the mutators. These guys are aggressive, they're creative, they try all sorts of wild new combinations. They have high diversity, but they create a flood of those API misuse errors, basically burying developers in false positives. You know, the researchers behind NEXTZZER said it perfectly. Talking about these replicator tools, they wrote, "These works have high accuracy but low diversity. It just nails their limitation. They're precise, sure, but they're stuck in the past. They can't find the kinds of bugs that require a totally new approach." And this isn't just some theory, okay? Take this real-world example. There was a nasty bug hiding in OpenSSL. To find it, you had to combine two specific functions in a specific order. But here's the kicker. Those two functions had never, ever been used together in any code out there in the wild. A replicator, fuzzer, which only mimics what it sees, would be physically incapable of ever finding this bug. No way. So how do you solve this dilemma? How do you get the best of both worlds? Well, this is where NEXZZER comes in. It's a new system designed to completely break that trade-off, aiming for the creativity of a mutator with the precision of a replicator. Just looking at its architecture, you can see NEXZZER is built to learn. It takes in info about the library, but the real key is that feedback loop you see on the right. It doesn't just blindly test stuff. No, it tries a combination, sees what happens, and then uses that result to make its next move smarter. This whole design is what lets it be both creative and intelligent. So NEXZZER's whole mission is to do what other fuzzers couldn't, generate all these diverse, creative API sequences that are still accurate. It's all about finding new vulnerabilities by thinking outside the box, like a mutator, but being smart enough to avoid the false alarms you'd get from a replicator. So how on earth does it do that? Well, the secret sauce is something the researchers call the learning graph. This is the core innovation, the thing that lets NEXZZERs adapt and actually get smarter over time. At the heart of this whole thing is the API graph. probably the easiest way to think about it is like a smart, self-updating GPS for the fuzzer. It's a map that shows all the functions in the library and, most importantly, the rules for how they can be used together. Don't call this function before that one, or this function needs info from that other one first. This diagram here shows that smart GPS in action. It starts with an initial map, the APIGraph on the left. Then, as it runs tests, it learns. When it hits a crash, that orange part, it doesn't just report an error. It learns the rule it broke and updates its own map, which makes the whole system smarter for the next test. It's this constant cycle of testing, crashing, and evolving. It's pretty cool. Let's just break that loop down into simple steps. First, it tests a new sequence. Second, it might crash. Third, and this is the magic part, it learns from that crash. It figures out the unspoken rule it just broke. Like it might learn, oh, okay, I can't call the free memory function before the use memory function. And finally, it evolves the API graph, adding that new rule to its map so it doesn't make the same dumb mistake again. So all of that sounds very clever on paper, right? But does this whole new approach actually work in the real world? Let's take a look at the verdict by the numbers. The first number is a big one, 27. That's how many new, previously unknown vulnerabilities NEXZZER dug up. And we're not talking about some obscure software nobody uses. These bugs were found in critical, heavily tested libraries like OpenSSL. These are serious flaws that every other tool out there had completely missed. Okay, next step, 93.96%. Get this. That's the percentage of false alarms that NEXZZER automatically identified and filtered out. Remember that whole screwdriver as a hammer problem? NEXZZER learned the rules so well that it could tell the difference between a real bug and a misuse error almost 94% of the time. That saves developers an unbelievable amount of time. And when you actually stack it up against other advanced tools, the difference is just staggering. NEXZZER isn't just a small improvement in filtering out false positives. It's a massive leap forward. It's really in a league of its own. And finally, there's code coverage. NEXZZER achieved up to a 48% increase here. That means it explored almost 50% more of the software's hidden corners and pathways than other tools. And more coverage means a much, much better chance of finding those deeply buried, really dangerous bugs. So let's bring it all the way back to that OpenSSL bug from the beginning. The one that the replicator tools could never find? Well, NEXZZER found it. By being creative and combining those two functions in a way no one had before, it uncovered that vulnerability. This is the ultimate proof that its approach, balancing high diversity with high accuracy, actually works. This brings us to a final, really critical thought. Our world is built on this foundation of code that gets more and more complex every single day. NEXZZER is a powerful reminder that to keep that foundation from crumbling, our security tools can't be static anymore. They have to evolve, they have to learn, and they have to become just as intelligent as the very systems they're designed to protect.